Hey everyone, I just want to give an update, a short, quick update on the development process of the my Moonshield engine, game engine. Uh, Basically, I said I had optimized everything, pretty much making everything independent of the core, and so basically what that means is rendering handles all the rendering stuff, and without the you know help of the core, or it's not in the core. And basically we make calls to the get stuff rendered to the screen or physics done through game objects, and which is a core functionality. So in our test game, so we can have our game, we can call the engine through the core and create game objects and onto our scene. um, Basically it's starting with creating the plane using a mesh. Um, we have basically a mesh, and also created a new figure mesh, which is a Blender model, an OBJ model, uh, and I've pretty much just optimized OBJ loading with dedicated mesh loading, you know, classes um, to handle that. So that way we, just been working on getting this stuff loaded in faster. By hand, just creating optimized OBJ loading and mesh loading. Uh, Basically, things are added to the scene through game objects again, like I said, and the camera is just another game object. It's a player cam, and we use the add object method to load that to the scene. And here's all the lighting objects. Again, it's just creating game objects using instances of a new, new direction light, new point light, new spotlight, and I've added those to the scene, and kind of creating myself a little note to tell me which colors they are. So this can get a little confusing, even with everything all cleaned up. So you can see, by cleaned up, I mean everything is called in their correct spots within the core engine, or within the engine. Sorry. Um, we have lighting, so it's just basically it's new game object and crawling all the necessary methods to create that to the scene. Like I had done before, I did forward rendering to create the lights. Now I'm starting to do mesh loading. I'll probably move into doing optimized terrain loading next, to just get things loaded quicker, more optimally. So I've created a test figure mesh, which is just another game object. That's the OBJ model. So set its position, so rotation of where he's in the plane. Um, you know, so that that's about it for the scene loading. I made a little sort of physics test to test the collider classes in the physics package. Uh, just a simple sphere collider. A couple spheres were created using basic math to create a sphere, and the intersect data class tests to see if they intersect. So here testing sphere 3 is false because it's a distance greater than 1. So basically anything 1 or less would be saying that the distance between the two radius of the spheres created here is smaller, so that means that it's intersecting. Or they're the same, you know, so it's one great, I think it's one or less distance, if I got the math right, that the radius is less than 1 or at 1, then they'll be colliding or intersecting, touching, whatever. So now I can show you, might as well just go ahead and show you what the game looks like. I hope that I explained that alright. Again, I'm still trying to understand it myself. Classifying lighting, the handling of lights as a component of the game engine. The core engine will obviously handle the creating of meshes through defining their vectors and transform to move things. Quaternion matrix 4F class to define, you know, rotation, movement, just, you know, projection, and the input class, you know, from the keyboard. So, you know, everything's handled through about right here. The core engine, game, and game object. You know, that's the interface to the game. The test game is going through these core components to, you know, make rendering calls, and the rendering package will create them, you know, create all that on its own. Doesn't need the core, you know, package to do any of that. It does it and sends it back to core, and core gives it to the game. And that's the whole point. I'm trying to, you know, and that's really what optimization means to me. It's just doing everything. Of course, you know, mesh loading can, you know, if you do things a certain way, of course, you know, it will load faster or whatnot, and, you know, take all this information from the OBJ file somewhat faster. Just depends on how you code it, but, you know, there's different methods, of course. But, you know, my frame rate seems to be high enough that nothing is taking too long to load, so I can go ahead and show you, you know, prove that and show you the game. Yeah, so all this stuff is created, and when you run it, you can see the scene created, and there's the lighting, there's the figure mesh. There's no, I haven't loaded a texture on it, but, you know, it's just straight from Blender. It's an OBJ model. You can see that I've moved the lighting so that, you know, we have the spotlight shining on his face, and the point light is centered on the floor. You can see the blue directional light is coming from that way, casting the shadow over the figure. And the normals look pretty good. Handling normals on the figure pretty well. And you can see things are reflecting correctly. The green light's reflecting, the red light's reflecting off his chest, his shoulder, even the blue light. So everything's pretty smooth, and yeah, this is real time. As you can see how the engine's running. You know, the frame rate I'm getting is pretty good. And, you know, when the game runs, you know, this stuff loads, and frame rate is 45, and the physics test is displaying based on, you know, the parameters we've given it. Alright, so basically, again, I can change things. Since this is blue, the directional light, I can go in and change that to, you know, white, and I can change the spotlight on his face to purple, something like that. I think that's correct, and I'm going to run that and show that. Yeah, so